Hi everyone, welcome to Skilled Inspirational Academy. Thanks for joining today's class. This is CCNA Day 3 class. Let's first start with Tier 3 architecture. First, I'll go with the theory session and then followed with the practical session. So now I'll give you an overview about Layer 3 architecture. So also the people, they call it as a Tier 3 architecture. This is widely used, in the enterprise network. This is a pretty common design anywhere you can see in the enterprise. Let me open up my whiteboard and I'll show you the Tier 3 architecture. I'll make a diagram and followed by the practical. Let me open up my whiteboard. Let me do a Tier 3 architecture here. I think we all might be familiar with this routers and switches, right? From the day one, we are learning about the routers, switches. So you know the functionalities of routers and what a switch router is capable of. Pretty simple design. This is how the conventional way of connecting the devices, right? But if you actually see, I got only two layers here. One is core, one is access layer. So instead of doing that, in the enterprise, I have more switches and the network is exponentially bigger, right? It keeps growing and I cannot have a similar kind of design. So that's when they came with the Tier 3 architecture. So the Tier 3 architecture, it looks similar to this. You got one router and additionally you got a core switch, a multi-layer switch. This is capable of both routing and switching. And you got one more access switch, L2 switch. Then you got your PCs connected to it, right? So this is called as distribution layer. And this is access layer. So in the distribution layer, you got both your L3 and L2. So as I told you in the first class, when we say L3 and L2, L3 devices works with IP address, whereas L2 device is a switch that works only with MAC address. So all your L3, your gateways will be sitting on the multi-layer switch. Say for example, I got two networks now, three networks for three PCs, right? So I'll mark this PC1, PC2, and PC3. For all these three PCs, I should definitely have a gateway, right? So the gateway is an IP address assigned to it. So if this PC wants to send a packet back to PC2, it has to go all the way back to the gateway. And then the packet will go back to the destination. Because this PC is not aware about the network which is configured on PC2. So what happens? The PC1, it checks, okay, is the IP address which I am trying to reach is in the same segment? If not, it sends a packet back to gateway. It's pretty simple like that. So for example, here, this PC is on 10 network and this is on 20 network. And this is on 30 network. 20002 is a different network, right? So this PC is not aware about this. So it going to send this packet back to the gateway. And from this gateway, the packet will be redirected back to the destination. So this gateway address is called as, here in the multi-layer switch, we configure interface VLANs. That's IP address capable. You can configure IP address inside this VLANs. This is called L3 VLANs. So let me take you to the lab now. This is an overview of tier 3 architecture. Let me take you to the lab. So there we can see exactly how all this configuration can be achieved. So to make this tier 3 architecture, I should have 3 devices. One is a router, and another one is a multi-layer switch, and then followed by an access switch. This 2960, just an L2 capable switch. And for testing, I'm connecting 3 PCs here. So I want to connect the devices, and we all know switch is a layer 2 device and the PC is layer 3 device. So I have to use straight through cable. If it is the same device, I should use crossover cable. And in addition, I want to say this. See, now in the current generation, there is no concept of connecting the cables with the crossover or straight through. All this is because of these ports are they are capable of auto negotiation. All these ports, whatever cable you connect to it, it can be either your crossover cable or it can be your straight through cable. It still works because of MDX. This is auto negotiation. Whatever the cable you connect, it tries to negotiate, and the link state goes up and it becomes operational and functional. So there is no limitation with the cable in the current generation. This is all pretty old, and just for your knowledge, I'm saying this. Even it's interview questions that I should always use the same kind of cables between these devices. But as a layer 3 device, I have to use crossover cable or straight through cable. You can go ahead and say this new modern ports are capable of MDX, and it's auto negotiable ports, and you can connect either cable. No worries with that. You don't have any problem with compatibility. Just for your information. So I'm going to connect this port back. So my connectivity is done. These ports are auto negotiating. The switch ports are auto negotiable ports. So let me go into the switch first. But before that, I'll give you step-by-step approach. So what is the objective in the lab? So first, this is access layer. This is distribution layer, or they call it as a core layer. So this is where I connect my internet. 3 layers. The ideology is I'll configure all my gateways back here, all my L3 IP address that sits in the gateway, and L2 is just L2 VLANs. To make it very simple, all my LAN connections sits on the access layer, just to reduce the burden of distribution layer. This is to consider for Tier 3 architecture. So let me go inside the switch now. If I give show VLAN, so all these ports, all my ports are assigned to default VLAN. One broadcast domain. Right? But my ideology is to create 3 VLANs, 3 broadcast domains. So one physical appliance, I got one switch, but my manager, he is giving me a task. Hey, I want to create this network into 3 networks. I have one switch, I have budget constraint, and we got about, only 20 users. So, but I want this 20 users to be sitting on different networks. In this case, you can split this. The Cisco switch is capable of, making into multiple broadcast domains. That's a use of manageable switches. Whereas in the home internet, we are using a modem, right? So that is not manageable devices. You cannot customize all these ports. So this is called as all these devices, the enterprise devices, it is called as manageable devices. You can manage. Whereas in the home routers, you have very less limitation and you cannot do any changes. That's a key difference you should know. And since I told you, I got one broadcast domain, but my requirement is to split into 3 broadcast domains. I'm going to do that with the configuration. So I'm in the privilege mode. With this hash, I can find out this is in privilege mode and I cannot do any configuration. We're all aware about that. And I'm going into configuration mode and creating an L2 VLAN. What is the command? So I'm going to give a command VLAN 10. And I'm giving a name. It is for HR. That's it. One simple command creates my L2 VLAN. And VLAN 20. So this is for finance. I have to give a keyword name finance. And then finally, VLAN 30. So for example, it's for IT. Name IT. So how to check all my configuration? Show VLAN. Right? I can see all my L2 VLANs created. So all L2 VLANs. So first thing is you have to create your L2 VLANs in the access switch. Access switch. You have to create your L2 VLANs. Then you have to assign the ports to the VLAN accordingly. 2 steps. First create an L2 VLAN, then assign the ports. So here I can see the free ports, but how do I find the ports that's connected, right? You're working from remote. You're not at site. How do I check the ports that are up and running, that are connected to the switch with this command? Show IP interface brief. Can you see this? This is the key thing to check in your output. So what is the status? This status is for the L1 status. Is it my cable are connected? Yes. The protocol is also up, right? I got 4 ports. So how do I check the devices that's connected to the switch from the remote perspective? Because I am not at site, right? The command that's used is show CDP neighbor. What is that? That is Cisco Discovery Protocol. That is used only to find the Cisco devices, not any other device, which is compatible to Cisco devices, right? So this particular switch will send the CDP packet, Cisco Discovery Protocol. It sends a discovery packets out of all the connected ports. And If a device is a Cisco device in the other end, remote end, say for example, in this switch, sorry, this is a switch, and I have connected to a router, and this in this particular port, it sends a CDP packet, Cisco discovery packet, and it tries to find the neighbor device. If it is a Cisco device, the same way it sends a CDP packet, right? If it is a non-Cisco device, no, I cannot use this command. You should use LLDP. That's called as, link layer discovery protocol. What is that? See, I can find the Cisco devices, but in my enterprise, I may connect any devices, right? Maybe a Juniper device, or maybe FortiGate, whatever, any vendor devices. I'll get this information back with the help of LLDP. The same way how the CDP works, the LLDP works in the same way, but that is, interoperable between devices. I may have a Cisco device and you are connecting a FortiGate, but still I can get this information back through LLDP protocol. Since I am using all the Cisco devices here, I'm not running the LLDP. I'm not pretty sure the Cisco packet tracer is capable of running LLDP, but let me try. Yeah. So this is the command you should run if that is the case. LLDP run inside the config mode. LLDP run. This is very important because you're working from remote and you cannot, see the devices, right? You cannot see all the devices connected to it. So only possibility is through your switches, through the outputs, through the commands, you can find the devices that's connected. So you should definitely make use of all these commands that would be helpful for you. So if every corporate and every devices, they'll be running with all this configuration by default, because since you're a network engineer and you're going to manage your devices from branch offices, definitely you should have all these possibilities. Only then, you should not depend on anyone, right? Because you cannot go ask your Spock for every time what is connected to it. So you should get the overview of what are all the devices that's connected to the switch, and you should make use of all these commands, and you should understand the use of this. As I told you, this is for interoperable. CDP run is also same thing. I think it would be running by default in the Cisco box. Show run. LLDP run command, just now I given this. By default, the box comes with CDP, but there is an explicit command. I'll try to show you that. CDP run. Yeah, same command, CDP run. Cisco box, it's by default. See, if this any specific command, if you try to find a specific configuration inside the switch, if it is not visible, then it is by default, because CDP run, this is by default running on the switch. So that's the reason you cannot see this. And now why I cannot see the devices, connected devices, because the port is not up and running, and anyhow this is not sending out any active traffic out, right? Show CDP neighbor. It's not showing any connection back. Let me go and check why is that. So I got a switch, right? And I have a device connected on port fast Ethernet 0/4. But why I am not receiving any CDP packet? This is how your troubleshooting comes in. So you have to find why I cannot see the CDP information back. So this is connected to fast Ethernet 0/4. So I have to give a command show IP interface brief to check the physical port is up. I go back and check this, the port is up and running, but I cannot see the switch. Let me go to this switch and see what is inside. So I cannot see anything inside. Show IP interface brief command. I'm going to check the connected ports. So I got 4 ports up and running, right? So one goes for the router and one goes for the switch. So for the, I want to trace this. So I think this is an L2 switch. And this is an L3 switch. Let me check. Show VLAN. So I created 2 switches. But how come I got both configuration here? This is multi-layer switch. I haven't created. Okay, it's by default. So to avoid this confusion, always change the host name. Yeah, let me change the host name to hostname core. So this is my core switch now. So give show CDP neighbor. Can you see this? From this switch, I can see the connected switch. This is my local interface. This is to consider. You have to imagine. See, this is a switch. The core switch here, right? I'm inside the switch. And the local interface. This is my local interface. Fast Ethernet 0/1. And what is the remote port that's connected to? That's Fast Ethernet 0/4. Switch. So my local interface is, this is local. This is remote port. So I got this visual, right? So this core switch is connected to this switch. Because of show CDP, I get this information. Hope everybody is clear. And also this will give you more detail, something like what kind of device is that? 2960 switch, right? Is it capable of what? Yes, yes is what? Switch. This is capable of switching. So very useful information you'll get from show CDP output. Definitely you should make use of this command in the enterprise support. And then let me go back to this switch and let's see why I cannot see show CDP neighbor here. Can you see this? I can see this now. See, packet tracer, most of the time, even you won't get some outputs. You have to wait. So because just an application, right? Not a real devices. So I think it could be a glitch, a bug. See now, can you see this? For this switch, right? Now I am in the switch, not core switch, L2 switch. Because we made a naming convention, right? Core switch and L2 switch. So I'm in the L2 switch and this is my core switch. So from here, I can make a visual diagram. See, from this switch, this is local interface, Fast Ethernet 0/4. And in the core switch is connected on Fast Ethernet 0/1. So I got it what exactly is. So this is my core switch, this is my L2 switch, and this is port Fast Ethernet 0/4 and Fast Ethernet 0/1 and the remote port. So now these 2 devices are connected and this is sending a CDP packet out of this port. And I'm getting all this information with CDP packets. If it is a different vendor device, I have to run LLDP. Then the same way I'll get all these details. Okay, let me do the configuration now. From the L2 switch, I'm done with the configuration. Let me go to the core switch and finish the configuration quickly. Show VLAN. I haven't created any VLAN. So what is the criteria? To make the core switch operational, distribution layer operational, to make the distribution operational, two criteria. One is I should have L2 VLANs. Second thing, I should have all my L3 VLANs. Both. Only then my distribution layer will start communicating back to the access layer. So what are the L2 VLANs I got? So I got VLAN 10, VLAN 20, and VLAN 30. Using a command, VLAN 10, VLAN 20, and then VLAN 30. So all my L2 VLANs are created. Then followed by my L3 VLANs. How to create that? I'm creating a switch virtual interface. They called as SVI because this is not a physical interface. Switch virtual interface, right? This is all virtual interfaces. You cannot see. This is logical interfaces. So interface VLAN 10, interface VLAN 20, and interface VLAN 30. Then IP address accordingly. Pretty simple. So I should have my L2 VLANs created followed by the L3 VLANs. If both are configured, then my switch is functional. Let me jump into configuration. I'm giving you a step-by-step approach to make you to understand, to make it as simple as possible. So let me create VLAN 10. Not giving name here. VLAN 20. VLAN 30. So I've created 3 VLANs, right? L2 VLANs. Show VLAN will show me the L2 VLANs which I have created now. So I got 3 VLANs followed by the L3 VLANs. So I'm in privilege mode, going to configuration mode and interface VLAN 10. Right, the state become up and running. I've created logical interface and followed by the IP address 10.0.0.1 with a default subnet mask. No shutdown. Followed by creating a second interface for VLAN 20 gateway for my VLAN 20 IP address 20.0.0.1 default subnet mask. So all class A address. We have a session I'll cover about the IP addressing and what is the range of IP address we should use for private and what is the public IP address. We'll have a dedicated session for that. But for now, I'm just going with class A addressing. Just consider we have 3 different networks and 3 IP ranges, 10, 20, and 30 for now, for your understanding. Then interface VLAN 30, right? IP address 30.0.0.1 to 55.0.0.0. I've created my L3 VLANs also. How do I check that? How do I check that? Show IP interface brief. Can you see this? VLAN 10, 20, and 30. So this is the proof that I have created all my L3 VLANs with IP address. So what happens now? So this is your switch and this is your core switch. You have one connection. that we call it as an uplink connection. All this traffic will be, traversing back and forth to the core switch with the uplink connection. And I got all my PCs connected to the user port. That's called access port. So now I created the L3 VLANs, L2 VLANs. So here I have created the VLANs. Only I can do L2 VLANs because this is an access layer and this is distribution layer, right? I have to assign the ports. This is pending. So I have to assign the ports to this PC. Only then it will be a part of the VLAN, right? Will be a part of my decide VLAN. So let me go back to the switch, L2 switch. Show IP interface brief. I'm not running any L3 VLANs here. Show VLAN. So by default, as I told you, all these ports are assigned to, VLAN 1 by default, but I want to assign the ports now. For now, I should know what are the connected ports to the switch, the endpoints. So I see 4 ports and I should not do configuration for the port which is connected to the router. That's fast Ethernet 0/4. This is connected to the router. So let me go into, the other ports, interface fast Ethernet 0/1, IP address, sorry, switch port mode access, switch port access, VLAN 10. What is the use of these two commands? This command will make this port as an access port. Only the endpoints can be connected. So first I have to change into an access port, then followed by the command switch port access and the decide VLAN here. Here VLAN 10. Yeah, I'm done with the config. Then I'll go back again, see fast Ethernet 0/2. So let me go back and see my topology. Is it the ports which I am referring to? So this is fast Ethernet 0/1. And this is fast Ethernet 0/2 followed by fast Ethernet 0/3. Okay. So fast Ethernet 0/1 I have assigned to VLAN 10 followed by interface fast Ethernet 0/2 switch port mode access. Always give this command first, make it as an access port, then switch port access VLAN 20, then followed by interface fast Ethernet 0/3 switch port mode access, switch port access VLAN 30. So how do I check? The ports are binded to the decide VLAN. Show VLAN. See 1, 2, 3. My ports are assigned to the respective VLAN ports. Let me jump in now and see what is the changes I can see in the core switch. So IP interface brief. This is very important to consider. Okay, see, all my L3 port status it's up and running only because this is very key thing to consider when you are making a design to your enterprise. See, you got your switch. Okay, so you have created all your L2 VLAN. Say for example, here I have created VLAN 10, 20, and 30, right? And you got your gateway here, the core switch. And I got an uplink connection back. This is a switch, this is a core switch for a differentiation. So if there is one specific port that's assigned to any VLAN here. Say, for example, here it's this port is assigned to VLAN 10 and I got a PC connected to it. If this port should be functional, sorry, if this gateway VLANs here, see L3 VLANs, interface VLAN 10, and I have assigned an IP address 10.0.0.1 and the default subnet mask value. See, if this particular L3 port, this gateway should, if the gateway should be active, I should connect at least one device to that specific VLAN. To make it very simple, here I have connected 3 PCs and all these 3 PCs are active PCs on all the VLANs which I have created so far. So one active ports on a specific VLAN should be up and running. Only then your gateway will be functional. This is the key thing to consider. Otherwise, your VLAN will not be up and running. If you have seen here, I've created all these VLANs, but it was not up and running before, but now it's up and running, right? Just because I have assigned the ports. Only then the VLANs will come up. The protocol is down. Why? I'll show you step by step. So now I created everything. I have created L2 VLANs, I created L3 VLANs, I have assigned an IP address, and I have assigned the ports to the respective VLANs. So what else is missing now? See, to make these 2 switches functional, right? I got my core switch, and this is my access switch. I got an uplink connection where all my VLAN traffics will be going like this, right? See, if you visualize, I'm sending 3 traffic, VLAN 10, 20, and 30. So let me make it a difference here. I'll draw with different colors. See, this is your VLAN 10. And this is your VLAN 20, right? An example, this is your VLAN 30. So actually I'm sending 3 network traffic in one single link. So it is called as, trunk link. And what is the protocol used for this? This is 802.1q. This is, IEEE standard. What is that IEEE standard? This is functional for all the devices, not only for Cisco. All vendor devices can make use of this. Device supports this. So that ideology is to send multiple VLAN traffic on a single port. So I want to check that, right? If I want to send all this traffic, if I'm not making it as a trunk, definitely my traffic will be blocking somewhere. Show interface trunk. So I haven't configured anything. So I have to see what is my downlink. So this is my access switch and this is the port. So I want to make it this as a trunk, right? Because this is where I'm receiving and sending a traffic back to the downlink. So it should be open for all the network, whatever I have created there. The interface fast Ethernet 0/1, switch port, mode, trunk. See, an interface whose trunk encapsulation auto cannot be configured in trunk mode. Sorry, this is pretty old switch. This 3650 is pretty old switch. So if I want to make it as a trunk, I have manually enable 802.1q protocol. If I enable this protocol, only then it start receiving all the VLAN information. All this tagged information, I can strip this and this switch can actually find out this VLAN based on this protocol. Since it's not enabled and it's pretty old switch, this run command, the direct run command is not working here. See, this works with your new switches. 3650 is pretty old, and I have to enable this manually. So what it says, it's a auto is not possible, but this is capable to, understand the 802.1q protocol. So I have to make switch mode trunk encapsulation .1q. See, I'm enabling .1q now. Manually, I'm saying the switch, hey, this is .1q. You should understand about the trunk informations, right? That's the use of this command. Then switch port mode trunk. See, now it's operational. Can you see this, guys? All these VLANs are up and running because now the switch understood all the VLANs because I made this specific port as trunk. Show IP interface brief. Can you see this? This protocol is also up, but earlier it was down, right? Can you see this? What exactly I did here? A quick recap. So this is my core switch. This is my access switch. I've created my L3 VLAN, L2 VLAN. I've created only L2 VLAN, being this is an access switch. So this is my core switch. I got all my IP address. Also make it simple as a gateway. All my gateways sitting in the core switch. And I got a connection back to the switch. I called from this switch, this is a downlink. And from this is an uplink connection where all my traffic is going. As we made a diagram with different colors to differentiate the VLANs that's actually, traversing back and forth between the switches. So my key point is I want to make these two end as trunk. What is trunk? Inside trunk, I am enabling 802.1q, and what it exactly does, it carries all the VLAN informations that I've created. This is very important to understand. Only then my gateway is operational. Now testing. Go to the switch. Go to IP addressing, static IP addressing 10.0.0.4, then 255.0.0.0 default subnet mask. And what is my gateway? To go check one more time, it's 10.0.0.1, right? So my gateway is 10.0.0.1. I'm done. Close this, go back to command prompt. Let me try to ping 10.0.0.1. I can ping, it boosts my connection. It's working, right? So let me try to do capture. You can see .1q information. STP and this is .1q. I'm trying to find the VLAN information exactly here. Okay, so let me try to ping another device. Let's start the simulation, go to real mode, go to IP config, and this port is configured for VLAN 20. So I'm giving an address in the VLAN 20 range. And then default subnet mask, and this is 20001. Close this connection back. Let me try to ping 10 network 10001. I can ping. Start a capture. Initiate a traffic to 10001. So from the switch perspective, I can see trying to find the VLAN tagging, the Ethernet port. Sending an ICMP, right? I'm pinging it. So it's using an ICMP layer 3, source 10001 and destination is 20004. I think this is not super accurate like the packet capture. I'd actually see the VLAN informations here. I cannot say, I think this is, packet tracer has some kind of limitation. So maybe in the next class, I'll definitely show you the packet capture and I'll show you the VLAN tagging information along with that. It's showing me the bridge ID, but not, nowhere it's showing me the VLAN ID, which I specified. It should actually show in the Ethernet frame. There is one specific header where you got an extra packet. You will get the information about your VLANs. It says VLAN 10 or VLAN 20. So that's how the switches can differentiate the traffic. Since it's a packet tracer, I mean, the packet information is not, giving us the detail with VLANs. So I'll create a lab in EVNG and show you the next class about the how we can strip out the packets, VLAN packets. So for now, my communication is working, right? This tier 3 architecture, this we completed, and I got a core switch and access switch, and I have created all this VLANs. And I hope everybody would have understood about tier 3 architecture and what is VLANs and how to assign an IP address, what is the different types of modes, and what is L2 VLAN, what is L3 VLAN, and how to create an interface VLAN, and what is switch virtual interface. That's an a different naming terminology for interface VLAN. Some people they call it as a SVI. In most cases they say, do we got a SVIs on the switches? So these are different types of terminologies you should understand from a network standpoint. So hopefully everybody would have enjoyed today's class, and I'm more than happy to teach you, and hopefully we'll meet in the next class. Thank you for watching. Yeah. Bye.